software, new values. We care about everything, literally everything, not only for drivers, but also for passengers, cyclists, and pedestrians. Everyone who sets out on a journey is important to us. That's why we want to transform the automotive industry and become its leading tech stack. Will this be easy? Definitely not. There are hundreds, thousands, millions of things to do. Thinking, rethinking, developing, software, services, new platforms, cloud, hardware, architectures, artificial intelligence, safety, data, security, privacy, scalability, usability, update, better features, even better features, innovation, speed, excitement. Excitement? Absolutely. We're giving everything to achieve this, every day. By developing a new platform for the automotive industry, we are reinventing the car for everyone. And we're pretty sure this will change the world. We are CARIAD. We transform automotive mobility.
Greetings, everyone. We wanted to start off the event in a bit of an interesting way with a video. And my name is Pavel Zornia, and thank you all for joining us today to the fourth SAA Stock live event on the topic of from manual to fully automated driving. The video that you've just seen was made by the company CARIAD, which is part of the Volkswagen Group. They mainly deal in software development for automated driving. And our guest speaker today is Doctor of Engineering Emil Gracić, who will tell us a bit more about that. And I will tell you a few short things, or better said, a few things about Dr. Emil Gracić. So, Dr. Emil Gracić is a functional safety manager at CARIAD, as we mentioned, which is part of the Volkswagen Group. And his main area of expertise is functional safety by others and automated driving systems. Software features based on visual perception and development of processes for safe and reliable AI development. Besides CARIAD, Dr. Emil Gracić has also worked at Hella Aglaia Mobile Vision GmbH and as a research assistant at the Department for Computer Architecture and System Programming at the University of Kassel. So as we see, quite the person with a very rich portfolio, and he is very rich in knowledge as well. In the comments, you can also see his LinkedIn and Instagram accounts if you wish to follow him, and I'm sure it will be of use to everyone. Thank you one more time for joining us, and now we will let Dr. Emil Gracić join us as well. Hello there. Hi.
Hello together. Can you see me? Can you hear me?
Yes, we can see you. We can hear you. How are you doing?
Excellent. I'm very fine. How you are doing, guys?
Great. We are also all great. We hope our viewers are also good as well. So,
awesome.
To start us, could you tell us, I've given a short introduction into your portfolio, into your work, but I'm sure that everyone and also our viewers would like to hear from the person himself a little bit.
Sure. First of all, thank you for a very kind introduction, Pavel, and guys from Ancora, thank you so much for this invitation and for having me here today. It's really a pleasure for me. And yes, as you just mentioned, we will talk about trends in automotive industry. From the video, you can also have an understanding what are the current trends, what are the challenges, and they are really huge. So because in the news, you can also find so much confusion whether some company has a fully automated vehicle on the road and or not. Will it be possible in 12 months or in 6 months? I think it's quite good to start with the basics, just to have an insight what are the levels of automated driving and what are the challenges there, and maybe to have some kind of to have some kind of insight into software development and AI. And if you permit me, Pavel, I would just share my screen with the presentation, and you can interrupt me anytime if you have some questions, remarks, or if you want to change discussion in another direction.
Of course. So let me just introduce the, essentially, we prepared also a few topics that are covered also in Dr. Emil's presentation. So he will tell us essentially where we are at today in modern society with assisted driving, what we need for fully automated driving, what are the different levels of driving automation. If I'm not on there, 4 or 5 levels, right? Yeah. And a bit more about the software behind the idea and more details as well. Okay.
Sure. Marvelous.
Now, excellent. We will now start off with the presentation in a moment.
Okay, just give me a second. And I hope you can see my screen.
Excellent. We can see your screen. Okay.
Okay, perfect.
Please share your knowledge.
Okay, good. Then, levels of automation. There is a standard called J3016. The guys defined ontology when it comes to automated driving, and they tried really to get with some useful definitions in order to gain common understanding. What is a dynamic driving task? What is operational design domain? What is automation level, etc. And they are talking there about 5 levels, or if you want, that are 6 level, if we say that level 0 means no automation, and such a car do exist till now. So what we have at level 1, we have a driver assistance, and it means the car, the system behind, is capable to support us with lateral or longitudinal assistance, with speeding control, speeding up, speeding down, or cruising control. And it is always either lateral or longitudinal. At the level 1, we do not have a combination of both of these systems. That is really important to understand. Typical examples are automated braking system, ABS, where you can set up, for example, configuration that vehicle is capable to perform braking if it detects a car in front of you 10 meters. And for steering actions, typical example is lane change assistance or lane keeping assistance, where the camera-based driving system is capable to detect the vehicle in front of you, to detect the road markings, road lanes. And if you drive too much in left direction, the lane marking will be detected and system will cause action and bring you in the opposite direction, and vice versa. At level 2, we have the same scenario as by level 1, but with an exception that the combination is allowed and possible. That means that we have steering control and cruising control in parallel. One good example for that is lane keeping assistance. And this system does the following. It keeps you in the lane, but it keeps you in the middle of your eagle lane. So it can perform some kind of speeding control, and it performs also a kind of steering control. So these are 2 very levels of automation. And one common thing for both of them is that the driver is responsible about, sorry, could you please maybe turn off your micro, because I'm getting continuously some noise.
Of course.
Thank you so much. Now it's much better. Sorry. One common thing for the both of levels is that we as a driver, as a human, are responsible for the driving task from its start till the end. And our hands must be on the steering wheel all the time. There is no exception, and there is no allow to put the hands back from the steering wheel and to have some kind of funny actions of comfort tasks like reading a book or chatting with your partner, etc. That is common thing from level 1 and level 2. At level 1, we are talking about DAS, driving assistance systems, and at level 2, we are talking about ADAS, advanced driving assistance systems. And now we are coming to interesting one. It is the third level. It is conditional driving automation. On this level, we have ADAS systems from the level 2, but with the assumption that the vehicle is capable to perform the driving task autonomously on its own, without our action and without our focus on the driving task. So what we can do here, we can put our hands back from the steering wheel, read a book, talk to our friends, have a phone call, whatever. It is everything allowed. And it is always restricted to a specific operational design domain, which means having a bunch of constraints, having a bunch of requirements where such a system can operate. Example given, it is possible to have it on the highways in Bosnia and Herzegovina, but not in Croatia. It is just one example. Important is at level 3 to understand that we as a driver are still in the loop. And if the vehicle, if the driving system fails, or if the driving system tell us that there are some issues, some problems, we have 15 seconds time from this message, from this alert, to take over the driving task. We need to put our hands on the steering wheel and to take the driving action on our own. And that's why we call this level conditional driving automation.
And one quick question when we're there. What kind of situations could those be when the driver would have to take over control?
So if you are driving on a highway, let's say, I think highway pilots are at the moment the most interesting stuff when it comes to level 3. You can have a very hard snowing on the road. And this is something what we call corner cases. And also we as a human driver are sometimes also not that much familiar with those situations. You have not that much good visible environment. And the system, the cameras, the sensor setup cannot operate very well. And that means we are on the restriction, or it can also come to some damage of sensor setup. It can come to some kind of hardware damage when it comes to performing specific algorithms from the software side.
Interesting. Thank you for that. And what would be, that would be level 3, and next would be level 4, right?
Yes.
Mm-hmm.
Level 4 is the same as level 3. But what we have there, we have operational design domain. And the automated driving system is capable to drive fully autonomously on this certain operational design domain, let's say in Bosnia and Herzegovina, but not in Germany. So when you are in Bosnia and Herzegovina, you can just press the button, your ADAS system is activated, and you can go back, have a sleep, work, whatever you want. But when you are outside of the operational design domain, that means that you are once again in the loop and you are responsible for the driving task. That is important difference between level 4 and level 3.
And how do we, maybe the question itself is wrong, but how do we design or set up the operational design domain?
So operational design domain is, as I said, a bunch of requirements. So you need to understand a lot of constraints. We are talking there about world ontology. You need to understand what are geographic constraints, what are weather conditions, what are season conditions, what are road conditions, what road type markings we need to detect and to classify, what kind of objects are relevant for us. It's really a crazy thing, but it's also really interesting thing.
I've also read once that Australia has a very interesting problem because the continent itself, it shifts for 2 meters every year, if I'm not wrong, and there were quite a few problems because of that.
Yes, yes, because you always have a certain defined camera setup. And the most important sensor type at the moment is camera, because with camera you can detect the objects and you can classify them. You can say, you can not just say, okay, I have this object in front of me, but you can also say it is pedestrian, it is tree, it is sea, whatever. And when we have a camera setup in the car, it always have some kind of calibration. And this calibration is static and dynamic. And the case you just mentioned is really challenging for dynamic calibration because you will not have the region of interesting of interest as you designed your system, and your system must be at some to some extent very adaptive and very flexible.
Is that the main problem at the moment, making the system as adaptable as possible?
Yes, yes, because we are talking about real environment, and we also need to be honest. We as a human driver also have some limits. You know, if you are driving under condition of heavy rain, of course you will have some kind of fear, or maybe you will just park for 1 hour till the weather condition is getting better. And it is, I would say, a constellation, a game between this adaptive understanding and reaction, but also about robustness of sensor setup, robustness and also realistic sensor setup. Because if you just take a look and analyze some institutes or some companies which are doing very good research stuff, they are equipped with the sensor setup from many of hundred thousands euro, and it is something what is not plausible and what is not realistic for serious production. So it is always a trade-off. What can we use and apply in serious production, and how we can manage all these challenges in regard to having a real environment.
Excellent. Thank you, Doctor, for that. And tell us, please, so I know maybe you mentioned also, but what level would you say we are at the moment, and what do we need to do to fully automate and essentially to be able to sleep in the car without any problems during a drive?
And to work in the car, not just to sleep. I think to the biggest extent, we are at level 2. There were a lot of announcements in last 8 years that we will have level 5 in 2 years, in 3 years, in 5 years, and after 8 years of effective development, all companies are more or less at the level 2. I will show you some examples with systems which are in serious production at the moment, but with a lot of restrictions. We cannot say it is a real level 3 or it is a real level 4. There are some announcements from Mercedes-Benz in December last year. They said they will roll out highway pilot, and they got a certificate for that purpose. It is the very first certificate for a car manufacturer, and the system is restricted to the speed of 60 kilometers. I don't want to underestimate it. It is really a huge commitment and really huge progress in this field. But when you're driving at the on the highway with speed 60 kilometers per hour, it's not that much, I would say. But it is a real huge progress, and I think the guys will be capable to come out with more suitable solution and with more comfortable solution.
Very interesting. And here's one more question while we're here. Are there, Doctor, you mentioned highway driving and all of that, but what about, are there many differences between driving in a city and on a highway? Is there a different set of challenges and problems with let's say, driving in a city?
Yes, driving in the city is much more challenging. And the driving in the city implicates a lot of much more scenarios that need to be covered. And that's why the automotive industry is trying to resolve this problem step by step, and starting with not that much high complexity. And that's why we chose highway as a first ODD. Level 2 driving functions exist already for city driving. You have very fancy and very good cruise control systems from Audi, from BMW, from Tesla also. You have also very good stuff with Volvo, which is in the past at least was cooperating with a company, Veoneer. And level 2 are present in city driving.
Very interesting, very interesting. And one more question. So obviously technology advances very, very fast, but I'm also, and probably our viewers as well, can lawmakers, can they keep up with technology? Are the laws also adapted to automated driving? Can one keep up with the other?
Yes, so what we are facing at the moment is a dramatically change of automotive industry. If we look at 10 years before, everything was about more comfort, more horsepower, better design, beautiful design. And now the key is the software. So I think the CEO from Volkswagen said once, the new cars will be smart mobile devices on the road. And that means you need much more software. And that's something what, when we look at historically, the original car manufacturer do not have this expertise, at least not at this very moment. And that's why Volkswagen Group founded CARIAD. CARIAD shall cover this topic and this area. Mercedes-Benz, for example, is closely collaborating with NVIDIA, the guys who have really good software development process and experience. Then if you take a look at the BMW, they are strongly cooperating and collaborating with the Israeli company Mobileye, which has excellent software when it comes to perception. Then in Sweden, you have the case where Qualcomm well-known and wide-established chip manufacturer, bought or acquired Veoneer, which is also company with very good expertise in software development when it comes to image processing and video-based software development. So I think we are all forced to go in closer collaboration with the software companies. And at the end, the main challenge is how to handle it in a scalable way, because Toyota and Volkswagen Group sell more than 10 millions of vehicles per year. So together they sell more than 20 then. And how to make this solution scalable? Because the software which will be integrated into Passat will not be the same as the software which will be integrated in Q7 by Audi or at Bentley, because they are premium marks. And this is really huge challenge. And I hope we will be able to answer, to respond to this challenge in the near future.
I think we all hope. We all hope we will have automated driving in the near future. Excellent.
It will be fancy.
Yeah, that would be really nice. I'd really like to take a nap while going somewhere to do something else as well. Excellent then. You told us a few things about why software is so important. What about AI? How does all of that factor in? Is AI sufficiently advanced? What other advances are needed for artificial intelligence to keep up, or better said, be more usable for automated driving?
Thanks you for that question, Pavel. If you allow me, I would just share a few videos about level 3, 4, and 5, so that the audience can also have a better insight. What does it mean on the road? So it was till now just about speaking about the topic, and I think it's also important to see how this system really looks like in the reality. And after that, we can use it as an entry point for the discussion about the importance of AI. Is it fine with you?
I'm sure that we would all be delighted if you could see those videos.
Okay, then just give me a moment. So we will see traffic jam assist as a level 3 from Audi, then automated valet parking from Daimler, Mercedes-Benz as a level 4, and future outlook from Waymo. It is Google Car. I think it's more recognizable than Waymo. So level 3, let's go.
If you could also, Doctor, give us a few. Oh, there's the video. If I'm not wrong, at the beginning we managed to see all the sensors that a vehicle has to have, essentially. On level 3, yeah. If you could give you also a few infos about the video itself and the technology behind it.
Yeah, sure. It's a really good point. Thank you for that, Pavel. There is no sensor type at the moment which can cover all scenarios and which can respond to all challenges. Example given with camera, you can detect and classify the objects. You can perceive the environment in a very good manner. But the problem with camera that it is really sensible to lighting effects. That is one point. Another point is with camera, you have a problem when it's when we have a heavy rain on the road, and that means that we have no availability of this sensor type at this situation, and it is not. It is something what happens really frequently. Radar sensor is really robust when it comes to lighting condition, when it comes to rain, but it is really sensible when it comes to snow. And the problem with radar is you can detect the objects, but you cannot classify them. You can detect, you can say in front of me is an object, but you cannot say, is it a car or is it a pedestrian or is it a tree? That is drawback with the radar sensor. LiDAR sensor is really good type, and it covers a lot of scenarios. But the problem with LiDAR sensor at the moment is it is too expensive. That's one argument. And another argument is you cannot detect the objects which are far from you. So you can detect the objects that just in the front of you, like 2 or till 10 meters. But when we are driving on a highway, we want to detect and classify objects which are far from us, like 150 meters. So these are 3 main sensor types which come into the game, and they are complementary. So that means we need a combination of them. We need a sensor fusion in order to have more reliable input and in order to produce more reliable output, where we are, what are the objects in our surrounding, what is the proper action we should take in the next step, etc. Does it answer your question, or do you need more details?
That was very interesting. But what do you expect? When would we have something that is not too expensive, something commercially available? Are there some predictions, maybe?
Yes. I think we are all working on highway pilot, which shall come in next years, and we will have a really complex sensor setup based on camera, LiDAR and radar. It will contain more than 10 cameras. There are also some good demonstrations from the guys of Mobileye. You can also find it in YouTube. They have a setup, I think, of 13 cameras, and you have a 360-degree view, surrounding view. And it is something what can be put in serious production. And I think we can expect it in next 3-4 years.
Well, that's very soon. That I expected something like 10 years or something, but 3 years is really that.
Pavel, we are working hardly, believe me.
Good job, and thank you for the hard work. I believe you also we've turned off the presentation, but I believe that in the presentation we also have some other additional slides as well. For our next question that we have prepared, the next question would be how to make cars essentially safe, robust enough, and Why functional safety?
Yes, then let me just show you this video, and then we can use it as a background for the answer. It is automated valet parking. It is level 4 from Mercedes-Benz, and it is a good point. Sorry, it is a good point to go in functional safety topic.
Of course. If you can also maybe give us a commentary following it, that maybe for some of the parts. Okay.
Sure. So this is a moment where we have a very strict, restrictive, and very high requirements on functional safety. And functional safety means when we are developing a system, let's say software system, we have some kind of normal risk. And this normal risk means that in specific situation, the system can injure society, human beings, or even environment. And you can see here, two guys are walking in direction of the car. And if the system is not functional safe, if we didn't develop our system in a manner that it is capable to reduce the risk at the minimal level, that means we can expect a lot of accidents, we can expect a lot of injuries, etc. And that's the point why functional safety is so important today when it comes to automated driving system. Functional safety starts with the complete system overview, or if you want, with the complete vehicle overview. And then we go and bring it down to certain components, to sensor parts, to processing part, to acting part, etc. And all these parts must be developed functional safety conform and must fulfill the requirements on a certain level. We are talking about 4 safety level in automotive industry from A till D, A, B, C, D. And for level D, we have really high requirements. For example, that one system must exist in 2 different forms. And that means that we have redundant system architecture or redundant software architecture. And it is not just enough to, replicate it. You need to have different teams. In best case, teams which do not know each other, one in Germany and another in India, etc. And it is really a science for itself, and we can spend a lot of time on discussion about it. But I don't want to go too much into detail because of the time restriction, and maybe we can also touch on other topics if it is fine with you, Pavel, and with the audience. But if you have more interests regarding functional safety, we can also proceed on this topic.
I'm sure that it shouldn't be a problem. We are maybe limited on time, but not that limited on time. If you feel that there's something that our viewers should know, I believe that would be nice for us, for all of us to know about it.
Yes, maybe just one hint. You have a normal software development and functional safety conform development. Functional safety conform development means you have to be completely transparent. And if you put a certain system on the road in the vehicle and an accident happens after 5 years, you are in charge to bring everything, all evidences from your development, and to show how you design the system. So it is also challenging in regards to configuration management, document versioning, document storage, long-term storage, etc. And maybe more important aspect regarding functional safety and difference in regards to normal software development is testing effort. When we develop functional safety or safety related software system, the testing efforts are enormously high, and you need to perform tests on the code level, on the unit level. You need to perform tests on the software integration level, where you have some kind of interaction between different software components, and then you need to perform qualification tests, and then to put everything in the context of system, software plus hardware, then system of systems, where you have a lot of features which are correlating with each other and interacting with each other, and the effort for testing is really not normal. So that is the main difference.
Sadly, testing is something that a lot of software developers skip, and sadly, especially integration tests, unit tests, more or less, people do write them sometimes for, but most of the time there are no tests at all. Thank you.
Yes, that's the problem, because people sometimes do not understand that embedded software is not something what we have on the web. And when you are working on the embedded software, you are always limited with the resources. You do not have 2 gigabyte RAM for your system. You may have, what I know, 300 megabytes for the whole software system you have there. And it's an interesting stuff in any case.
Excellent. Now that you mentioned embedded systems, are we reaching currently some limitations as far as embedded systems go? For example, let's say, I know that temperature, I believe, can also be a problem. Energy consumption especially can be a really big problem there as well.
Yes, that is a really good point, Pavel. Thanks for that. When you look at maybe the best hardware system at the moment for automotive, which was designed by NVIDIA guys, you have a lot of resources, but the power consumption is enormously high. And this trade-off between resources and performance is not given. That's something, that is the reason why we also try to have very complex hardware architecture with a lot of system on chips in parallel. But someone said the companies who are working seriously on software development also develop on their own hardware, and that is also a key point. That's something what Tesla is doing at the moment. NVIDIA, Volkswagen is also planning such activities. And for the fuel-based vehicles, power consumption is still okay. But if you are driving the electrical car, fully electrical car, then the power consumption is really critical. And more critical in case where you have a radar sensor as an input, because radar sensor is also a guy which is consuming so much power and so much energy.
Yeah, that's especially because battery technology can't keep up, essentially. That's the biggest problem there.
Yes.
I know that I've read quite a few articles, blogs, and everything, that a lot of companies are focusing now on developing better battery technology to combat exactly this problem. Interesting. Nice.
Yes, sure.
Lovely. Great, thank you for the additional information as well. Now, I would also like to ask you to share some few other questions as well from user perspective. So this is not, let's say, not such a tech question, but how do users perceive automated driving? I'm sure that you also had to deal with a lot of studies, more or less with focus groups, perhaps, and similar. And what do users think? Do they feel safe at the moment with the current, let's say, state of technology as far as automated driving goes?
That's a really interesting question, Pavel. Thanks once again. Then let's take a look on the video of a Google car of Waymo, and then we can get back to question, because the audience which tested those cars also gave an input or an feedback. How do they feel while automated driving, while they're sitting behind and the vehicle is driving on its own? And then I can give you some insights and details about statistics, what the people in Germany think about, what the people in USA think about, etc.
Of course, that would be great.
So then I had it somewhere here. Go, Zack.
You may be able to hear all everything that was said, but could you give us also a quick summary of the video as well?
Yes, and I think you heard that the guys have something about 180 camera systems. So, and you can imagine how much expensive it is. And the Waymo guys are doing the excellent job. But this is something what cannot be put in the serious production. You know, you cannot sell even 1 million car per year with this sensor setup. But it is a good for research. It is a good for making a progress, for challenging the status quo in the automotive industry. Another thing, you also saw the reaction of the people who were, you know, trying out this system, and they are not that much trustful. So when you are in, you must put your trust on the system, and it's something what is also biological to the human. You trust to someone who you know, and not to something or to someone who is a stranger for you. I think last year there was a statistic in Germany how much people would trust to an automated driving system, and that was just about 30%. So I think it's not that much. We need much more confidence. We need much more trust in this area. And as I said, we are still at level 2. Although some companies are trying to, you know, sell their cars as a level 4 or level 3, we are still at level 2 in 95% of the driving tasks. So we need to go step by step, and I think on the other side, it is also some kind of human arrogance, because we always like to underestimate the complexity, and we do not assume problems as realistic. I had as a student, I had a course of artificial intelligence, and the professor was talking about a first cheese program. First cheese program was developed, I think, in the middle of 60. And the people, the humans, were so impressed, and the guy said, we will have in 3 years a cheese program which can master all human cheese masters in the world. 3 years. And the people needed about 35 years to solve this problem.
If I'm not wrong, Deep Blue was the first adjustment that managed to beat Kasparov, and then Deep Blue 2. Yeah, it's an interesting story. Interesting, great.
And I think we are in a similar situation once again, because in 2014 to 2015 was a time where people said, in 2 years we have level 5 on the roads, and after 8 years we are still at level 2.
We always like, essentially what people, we always like to aim big, to dream big. We kind of end up
and to gain small achievements.
Excellent then. Thank you. Now, I think we will also have to wrap up slowly now the live event as well. Doctor, do you want to give us some closing words also for?
Yes, maybe as an exchange from classical software development to AI. We saw that we are dealing with complex fundamentals of perceiving the environment, planning a proper action, and executing a proper action. When we are developing the systems based on classic software, we are always restricted to a certain number of cases. That means when we program 1,000 cases, it is our limit, and the system is not capable to learn more, to be adaptive, to deal with new scenarios, with unseen scenarios. And that is a lack of generalization. And that was the reason why we need a transfer to AI software, because AI was originally inspired by a human brain, and we as a human are capable to do exactly this process, generalization. So if we see 3 or 4 times a certain object, then we can have a clear picture about it. And if we see it in another version or in another environment or under another conditions, we are in capability to make this process generalized and to detect this object as it should be. And that's something where we need AI. AI is capable to perform this process very well. And it is not about algorithmic side. Algorithmic side is really important at its classic software development. By AI, we have more or less well-defined architecture or algorithmic architecture, and it is something what we cannot touch. But what is important and what brings us to generalization is the data, and we need to use a lot of data. We are talking about, how to say, terabytes, and just for the training of one deep neural network, and we need to retrain them, and we need always to gain more and more diverse data in order to have this generalization process better and better. And that's the point where the trends in automotive industry are going on. I would say more and more AI, more software robustness at the sensor setup, and have this scalable solution for more than 10 millions of vehicles per year on the road.
Well, I have to admit now, this was quite the summary of today's topic. Thank you, Doctor, for that. Now we will more or less for the ending, we will show one more time the video that we had at the beginning, the promo video from CARIAD.
Everything is digital. Our world. Our lives. Bits, bytes, likes. Always on. Always connected. Always. Cars are not fully connected. Yet. The digital revolution has just begun. On the road, you can already find restaurants, stream music, or navigate in augmented reality. But we can do more. Much more. We want to rethink the car, make it smarter, more comfortable, safer, more entertaining, more sustainable, more digital. A new automotive experience with new technologies, new software, new values. We care about everything, literally everything, not only for drivers, but also for passengers, cyclists, and pedestrians. Everyone who sets out on a journey is important to us. That's why we want to transform the automotive industry and become its leading tech stack. Will this be easy? Definitely not. There are hundreds, thousands, millions of things to do. Thinking, rethinking, developing, software, services, new platforms, cloud, hardware, architectures, artificial intelligence, safety, data, security, privacy, scalability, usability, update, better features, even better features, innovation, speed, excitement. Excitement? Absolutely. We're giving everything to achieve this, every day. By developing a new platform for the automotive industry, we are reinventing the car for everyone. And we're pretty sure this will change the world. We are CARIAD. We transform automotive mobility.
Essentially, that was the video one more time. I get goosebumps every time how good the video was made. In any case, we would more or less stop the event here. Thank you very much, Doctor, for joining us today, for being our speaker on our topic. I mean, I learned things that I had no idea about. We managed to hear about what the current state is of the technology, what we will have in 2 or 3 years. I'm keeping you by your word. And thank you one more time for joining us today. And I thank our viewers as well for joining us and listening to an excellent topic.
Thank you also from my side. It was really a pleasure to be with you today here. And guys and the audience, if you have another questions or topics for discussion, you can ping me on LinkedIn or on Instagram. You just got the links shared, and we can have also another discussions in person. It's fully okay.
Of course. Lovely. Then. Thank you one more time. And that would be it for today's event. See you.